provide you a series of advanced product quality planning webinars, and today's is focused on the process flow and the process failure modes effects analysis components of APQP. So myself, my name is Tam Toe, and I'm a quality engineer within the Boeing Company. You'll hear later today from Daryl from formerly Honeywell and Steve Webster from UTC. So, and then finally, Sue will help with our Q&A. All righty. As I mentioned, I will be talking about the process flow. Daryl will be talking about the process failure modes effects analysis, and then Steve will bring it all together and show you how those link to the design risk analysis and the control plan that will be discussed in an upcoming webinar. All right. So the product supply chain improvement team and the 9145 deployment group wanted to create these webinars based on a subset of key tools to help you get started. These webinars are meant to provide a high-level overview of those critical tools, share those benefits and best practices, and additional information and where that is located. So today's webinar, or just a reminder before we begin, last two previous sessions, we gave an overview on advanced product quality planning, but we wanted to bring this up again. Advanced within advanced product quality planning means that the activity is happening ahead of or greatly developed beyond at the initial production stage. This does not mean that it's cutting edge or new. These tools have been around for decades, and the when and how they link together is what makes APQP what it is. The product in APQP means the items that are being marketed or sold. The quality is a key component, is the degree of excellence or how good and effective the activities are. It does not mean that the quality function is the only function that's involved or owns APQP in its entirety. While it's the contrary, it requires that the cross-functional representation is taken into account and spans the entire product life cycle. And then finally, planning is the establishment of the activities to achieve these goals. So in application of APQP, we will spend more time upfront to help improve quality, on-time delivery, safety, and help reduce costs and customer disruption. So AS 9145 is mentioned throughout this webinar and is the aerospace industry standard for APQP and PPAP. So the webinar today will just give you a high-level overview of the key concepts of the process flow diagram and the PFMEA. We will walk you through the 9145 requirements pertaining to these elements. We will give you a high-level connection to the design risk analysis and the control plan, and then we will help you get started by identifying some reference materials. All right. Here is the You Are Here chart. It's a simple, non-comprehensive chart that shows you the APQP deliverables in respect to the 5 phases of APQP. Today, we're talking about the process flow and the PFMEA, which are part of phase 3, process design and development. And if you notice, phase 3 happens concurrently at various times with phases 1, planning, phase 2, product design and development, and 4, product and process validation. So the design risk analysis and the key product characteristics are key inputs to the elements that are being discussed today. Here we have an image taken from the IAQG 9145 deployment support materials. that captures the activities and deliverables for phases 3, process design and development. The areas circled in red are what we're covering today, including creating a process flow, conducting the PFMEA, updating the process based on risk mitigation plans, and those deliverables are process flow, PFMEA, and process key characteristics. So let's talk more about the requirements within 9145. Section 4.5.2 states that the process flow and the PFMEA are elements of the production part approval process file and may be required for PPAP submission as determined by your customer. Section 4.5.3 states that the process flow diagram shall include all operations in sequential order from receipt of materials through storage and shipment. However, it doesn't quite dictate what template you use, so keep that in mind. Section 4.5.4 states that the organization must use the PFMEA methodology as reference in J1739, or unless an alternate method is required by your customer. So the key takeaway from this is to make sure you work with your customer to understand those requirements. So moving on, why is the process flow so important and why do we have it in PPAP? So variation is inherent in every process. A key portion of APQP is the management of that process variation. So as we're trying to minimize the variation, we want to thoroughly understand where it comes from within the process. A comprehensive process flow diagram can help you get there and help you locate where those sources of variation are. Well, what is it? It's essentially a representation of sequential steps for a manufacturing process. This may include the operations from receipt of material through storage, packaging, and shipment, or a subset of those operations as deemed by your scope. This encompasses the movement from product internally from one step to the next, as well as movement to and from external operations. The purpose of a process flow diagram is to help us see the real process. This may be in the form of a visual diagram, a visual or table, or input and output form as shown to the left. These are only a few examples, but to help people see to assist in the fact that everyone may see things differently, you'll want to use what best fits your organization. And the key point is to make sure that it can flow into the process failure modes effects analysis. An additional key objective is to understand characteristics of the process, including the step-by-step process linkage, the inputs and outputs of each process step, any activities, offline activities, including measurement, inspection and handling, and any planned or non-planned rework. It also assists in the identification of needed resources and the planning thereof. So it's a good resource to help you do that. Well, when do we use it? In respect to the APQP methodology, the activity should start once the preliminary design is released. It should be built upon the preliminary process flow created in phase 1. That's oftentimes where it starts. It's critical that it happens prior to the process failure modes effects analysis, as it's a necessary input. And then finally, it's updated as the process change. This is indeed a living document. So once this document is released, the changes must be revision controlled. So what are the benefits? As Louis Pasteur states, in the field of observation, only chance favors the prepared mind. So the process flow and its outputs help prepare an organization for further success in using the process failure modes effects analysis and the control plans. So a few other key benefits include it enhances common understanding of a process by visually and/or descriptively showing the step-by-step process. It describes the process comprehensively. It identifies where those product key characteristics are created and how it can be affected by neighboring processes. It identifies the hidden factory. For instance, those can include workarounds, rework, wait time, inventory, or defect. It also includes those alternate processes. And alternate processes are different processes used to achieve the same output. For example, backup equipment, secondary sources, or sequence changes. And then finally, it provides that linkage that we've been emphasizing in relation to APQP, to the process failure modes effects analysis and the control plan. So what does it take? It's a team effort. Firstly, you want to establish a process owner and that cross-functional team. A process flow creation depends on the input being provided, which may be, but not limited to, the current methods being used, the operator skills, and the engineering requirements. So it's key to consider those as you're establishing those cross-functional team members, as they will be bringing their personal experiences to the table. Other necessary inputs to the process flow include the preliminary process flow created in phase 1, the design risk analysis and design records, including those product key characteristics, the bill of material, what's required to produce that product, the current tooling and equipment, or the planned tooling and equipment, and then the list of outsourced process steps where it's known. When you create a process flow diagram, the first step is to make sure that the preliminary process flow from phase 1 is updated to reflect that the latest design, bill of material, and process details to that maturity. The team then reviews the process flow to ensure that all steps are included and completely describe the process required to receive, make, inspect, test, protect, and store and ship the product. Alternate processes and the movement of internal and external operations are checked. And then at this point, you want to make sure that you walk the process if that's available. And if it's not available, then find the next best process to walk, because that will help you identify that hidden factory and provide a better visualization of what's happening. Then you'll take the product key characteristics and incorporate them and make sure that they're identified. And then the proposed process flow is then reviewed by that cross-functional team again for concurrence. So as changes are incorporated throughout the product lifecycle, we want to update the process flow. To help you in creation of these process flows, the checklist can be found under the Supply Chain Management Handbook, and that can help you get started. Here's an example process flow for the fuel air manifolds as captured within AS 13004, created by the Aerospace Engine Supplier Quality Group. This provides a good how-to on process flow, PFMEAs, and control plans. This slide captures the sample process flow, and Daryl will be using this to help show some of those key connections from the process flow to the PFMEA. So finally, I want to emphasize that a comprehensive process flow will help create the foundation of an effective process FMEA. So now, Daryl, would you mind introducing yourself and discussing PFMEA?
Sure. Good morning. Good morning, good afternoon, good evening. I'm Daryl Brunswick. Tim, you can hear me, so everybody else can hear me? I had a little technical difficulty in the middle of yours. I got kicked off the system. I got kicked on, so hopefully that won't happen. But I am retired from Honeywell. I was with Honeywell 40 years. I worked in the automotive and aerospace sectors of automotive. I performed APQP in both sectors and managed the APQP group that oversaw purchase product, APQP purchase product for aerospace, Honeywell Aerospace. So you can see I'm still active and still working. And I want to thank Tam. She did a wonderful job of the process flow, which is really a key point of preparing you to do the PFMEA. So let's move on to the next slide. Okay, so what is a process failure modes, effects, and analysis? Well, like we've said, it's a structured methodology for identifying all possible failures and impacts to the process. What is a failure mode? So these are two good definitions you want to put write down, keep with you, because this is where confusion comes in. A failure mode is the description of the non-conformance to requirements. So you have a requirement, it's not what your product is showing that it's not meeting the specification, not meeting the requirement. So that's your failure mode. The effects is the study of the consequences of those failures. So prevention of controls emphasized over detection where feasible. We always want to be able to prevent the failure mode from occurring, or if it does occur, from moving to the next operation, to the next step. So those are prevention, and those are highly highly sought over controls. Modes are points. Failure modes are prioritized according to how serious are their consequences, how frequently they occur, and how easily they are to detect. Reaction plan then is constructed to eliminate or reduce failure modes with high severity, reduce occurrence, or improve detection. So that's what a PFMEA is. When do you use it? With 9145, it's when you're launching a new product or service, when you're designing or developing a new manufacturing process. But also it's a living document. So to improve our existing process, or when you want to make significant changes to a product, when you do work transfers from one site to another site, from inside to outside, you want to do PFMEA process maps. The process should be the same, but there are always changes in the process. What's the purpose? Again, identify potential product related process failure modes, assess the effects of those failure modes, identify the causes, plan for, I'm going to say, prevention first, mitigation, elimination, and control of those failures. And it becomes the repository for lessons learned. So 9145 says you shall do lessons learned. This becomes the repository for lessons learned. The right-hand side of your reaction plan is your lessons learned. I want to emphasize that it is best to do these with a cross-functional team. You need more than one person. You need to see the whole thing. So get a cross-functional team together and do these. And we'll go into that a little more. Well, let me just go. Who could be in the cross-functioning? The core team could be your manufacturing person, production, and quality. Those are pretty much core. Extended team would be design, maintenance, facilities, test equipment, engineering, anybody that has a knowledge of the process. So those are always helpful. Next slide. So we like these little sayings. So Benjamin Franklin always says, success is the residue of planning. And that's, to me, that hits home pretty good. The key benefits, it helps to identify critical process parameters and process key characteristics, reduces repair, rework, and scrap. Dollar signs are wrapped around that one. Identifies design and manufacturing changes early in the launch process. And that's what APQP tries to do, is get you a quality product at launch. So you're doing these things up front and doing these things before you field a product and then you have a problem downstream. Prioritizes actions to prevent, reduce, or contain nonconformances. Provides a linkage to the control plan. There's back and forth between the control plan and the PFMEA. And again, a repository for the lessons learned. Okay, so how do you get started? So again, it's a team effort. You want to establish your team. You should have a team leader, and the team leader should define the scope, the roles, and the schedule. So you want to say, what are we looking at here? Are we looking at receiving to shipping? Are we just looking at the milling operation from receipt of product into milling to shipment of product to the next step? So what's your bookends? What's your roles? Who's going to do what? And hopefully you'll establish the schedule when you meet. You want to move the PFMEA along. You don't want it to stagnate the process, but you have to take time and do it right. So to sit down and do these at one time, typically that doesn't happen. You're going to have to come back to it and look at it. Who should be in the cross-functional team? Engineering, manufacturing, quality, operations, and you do have extended team members as needed. Highly recommend you use subject matter experts, and these would include the process subject matter experts, but also if you have somebody, a PFMEA expert, somebody to help you navigate through the PFMEA if you're first time putting it together. And that's the facilitator. Include the facilitator if you can. So the rules are product design will meet product intent. So that is, you don't look at design and say the design's bad. It might lead to that, but as designed, the product will meet the intent. It may lead to that when you get to tolerances and how it's put together, but you got to assume the product is designed and meets the intent. And that's the requirement, the output of the DFMEA, not the process FMEA. The product or material coming into the process is conforming. So everything that you receive into that process meets specification, is conforming. So you can't blame a bad part on the previous process. When you score severity, it can only be changed by a design change. So severity score can only be impacted by a design change. And you want to have a defined ranking system for your severity, occurrence, and detection. You want to stabilize on one system and use that throughout your process, throughout the organization. And that way you are using a common scale. Now there's various scales out there, as Tam alluded to. I think 1739 is the automotive spec. After AS 9145 was written, 13,000 AS 13,004 was written for aerospace engines group. It has severity and occurrence scoring that's more attuned to aerospace volumes. So it may be better fitted for what you're doing. So what are the inputs? Process flow diagram, definitely a process flow diagram. The better the process flow, the better your PFMEA, the better you understand your process, the better you'll do your PFMEA. Any kind of performance data you have, similar parts or processes or development runs, what's your yield, what's your capability? So you'll need to know that. If you can start with a similar to PFMEA and build on that, that is the way to go. Build on similar tos or like processes. You'll need your design risk analysis. That is your DFMEA. That'll identify your product key characteristics. So we have the key characteristics, and then you have your control plan. Again, control plans from similar parts or processes, or it could be your development inspection plan that's going to grow into your control plan. So when you're first doing it, you may not have a control plan, but you'll have a type of inspection plan. So you may build your control plan and your PFMEA at the same time. So those are inputs, and they go back and forth. All right. I think I hit everything there. So let's construct it. And what we don't talk about here, which I want to highlight a little bit, is the top part of this is what we call the header. So the header is not blocked off here, but you put your company information, you put your team members down, you put whether it's a pre-production PFMEA or production FMEA, you put the part or the operation number you're working through, you put the date it was originated. If it's been approved, you put an approved date in there. So you put your information in your header as you know it. So, but the bottom below the blue line is where we're going to talk. What goes under the blue line? So your process steps, these are aligned. These shall align with the process flow. So this is your lockstep with the process flow. So the process steps are aligned with that. If they have a operation number, use the operation number, use the description of the process. What's the output of the requirement of each step? What am I trying to do here? Drill a hole to a certain size, drill a hole to a location, cut a piece to a certain length, assemble 3 parts together to make an assembly. So what's my requirement of what's my output? So that's that output. So what's on the drawing basically is what you want to say here. So what's on your product specification you want to try and delineate here. Identify the ways each of those then requirements could be not met. When you're drilling a hole too big, hole too small, hole in the wrong location, bar too long, bar too short, unit didn't assemble, torque on the screw didn't get met. You know, maybe it's you have to torque them down to so many inch ounces or foot pounds, and you over torqued them or you under torqued them. If it never tightened up, or it never the assembly never went together because it over tightened and you had a strip screw or maybe a screw that locked up. So what are your failure modes? How did you fail to meet the requirement of the drawing? That's the big one again. How did you fail to meet the requirements? Next slide. So this is how the process flow in the PFMEA relate. Your outputs, as we said, your outputs are your drawing, your requirements are become the output relates to the failure modes. What way could a requirement potentially not be fulfilled? So that's how they relate. Your outputs in your process flow diagram, the opposite or the non-conformance of that becomes your failure mode. Next slide. Okay. For each failure mode, identify the consequences. And these should be in the eyes of the next operator, maybe even your operator, maybe in your operation that you're doing it, the next operator, the company, the customer, the end user. So look at all those divisions. If I'm drilling a hole and I'm running a drill press and I run 3 parts and all of a sudden I see the second part, I missed a hole. Well, that means I have to go back and rework it or reset it or maybe scrap it. The next guy can't use it because he has to use that hole for an assembly. Or maybe it gets to the customer and the hole's in the wrong location and now the function of the product doesn't work right. In the case of the fuel manifold, maybe you have reduced flow and it's a reduced flow, or maybe it won't assemble. So what's the effects of the failure based upon who uses that part in the company, the customer, or the end user? And then you go into why that failure mode occurred. What are the causes of that failure? The causes has to be related to the input on the process map. So you list all possible causes for each failure mode. So what are the causes for that failure mode? Is if my hole's too small, did I use the wrong drill? Or if it's too big, did the drill walk? Was the drill dull? Those are the causes are related to your failure modes, and they come right from the inputs of your process map. So if you want to look at your next slide. So again, identify all the consequences in the eyes of the next operator. Just reiterating what we said, these are your potential failure modes. The potential cause of failure, the purple block, relates to the PFM as inputs. A potential cause is an input that was not met, is insufficient, or not followed as intended, or variation. So those would be causes. So maybe you're trying to weld something together and you didn't get it hot enough for the weld to work. So it was insufficient heat. So now you have and then one thing I want to tell you, you work the PFMEA down the column instead of across. We're going across, but you typically take an operation and you work it down. You put your process step, your descriptions, your requirements, then you put all the failure modes, and then you put all the effects of those failure modes, and then the causes. If you try to go to cross, in my eyes, it doesn't work as well. You get confused. So work it down and then move across. You may take it in blocks of a process or maybe a feature, and then work a feature and go across, but work it down. So you list all the prevention controls that would mistake-proof the error from occurring. And you'll notice that we have the prevention controls on this form, and that's maybe a change, maybe you haven't seen it, but prevention is on the left side of the occurrence number, because prevention controls impact your how often that occurs or how often you'll see that. So prevention control impacts occurrence. So what prevents me from making a hole too small or too big? Do I have a drill checker online? Do I have an inspection for length, inspection for length right on the machine that says, that one's too long, too short, so it kicks it out of the machine, doesn't even let it go to the next operation. So prevention control. For each cause, identify the current process that would detect that failure if it did occur. So these are detection controls. These are test procedures or mechanisms that you have in place to keep the failures from reaching the customer, maybe the next operation, the customer. Maybe they're an inspection downstream. They could be a test downstream. They could be an assembly test downstream. They could be end-of-line inspection. These controls that might prevent the cause from happening, reduce the likelihood of that it happened, or detect the failure after the cause has already happened, but before the customer is affected. So these are your detection controls. Next slide. So you have all your language down, and now you're trying to scale these things to how significant are these. So you rank severity from a 1 to 10 scale. And let me say there's scales out there. The J1739 scale is a good scale. The AS 13004 has good scales in it from the aerospace, but be consistent in your scaling. And so severity is ranked from 1 to 10, where 1 is insignificant and 10 is catastrophic. 10 in severity says you have a failure that's going to cause bodily damage without warning, or significant failure without warning. A 9 is with warning. Not much difference there, but there is a difference. A 3 or 4 may be that you have to a production loss and your jeopardy of losing the order on not being able to deliver the order on time, and you have to rework the product. So it looks at time and money and event and catastrophic failures at the end to bodily damage. And then you rank your occurrence from 1 to 10, where 1 is extremely unlikely and 10 is inevitable. Again, these are based upon time scale, how often they occur, 1 out of every lot, 1 out of every month, 1 out of every week. If you can capture yield, you can capture PPM, it's related to those as well. So you rank them from 1 to 10. And then you rank your detection. Again, 1 to 10, 1 means the control is absolutely certain to detect the problem, and 10 means the control is not certain at all. You don't have no inspection, no control exists. So you rank those. Again, your scaling sheets should give you a good idea. I like to use separation. I don't want to get into arguing about, is it a 4 or 5 or 6? It's a 5. It's not a 7. It's not a 3. So try and look at separation when you're doing your scaling. When I do severity or I usually say, did it impact the operator? Did it impact the facility where I'm working? Did it impact my end customer, or did it impact the user? So I put it in 4 buckets there and trying to say, what's the impact? Next slide. So you take all those numbers and then you multiply them together and you get your risk priority number. So severity times occurrence times detections gives you a risk priority number. And this is the number you use for guidance of which one of these failure modes to work on first. And you look at those, you multiply those together. What I like to do here is once I do the multiplication together, I sort the file by highest number at the top, and I say, are these really my expected pain points? Is this really where I have scrap in the bucket? Is this really where I'm getting returns from my customer? So those should be your high RPN numbers. And if they're not, maybe you want to go back and look and do a sanity check. But that's where I start looking at saying, does this really make sense? So are my high RPN really numbers really my items I need to work? And people ask, well, what is the threshold for your high RPN? Again, the rule of thumb has been always a triple digit number or higher is something you want to investigate. I say you can't work on 15 things at one time, so you want to take the top 5 or 10, 5, and work on those 10 if they're grouped, and work on those and keep working them down. If it's a brand new process, you may have to put more effort into it, and there may be some high RPN numbers that are, the quantity is more than 5 or 10. So you may have a lot of opportunity to work on, but again, it's a rule of thumb. It's based upon what your organization uses or what your customer desires, but you want to work on the top ones for sure and work your way down. Okay, next slide. When you do get, classification. So this is where, if it's a KC listed on the product key characteristic is an attribute or feature, this is where you put KC, process KC, critical item. This is where you put your nomenclature there for those features. Again, your key product key KCs come from your DFMEA or your product or your design risk analysis. So again, product key characteristics are attributes or features whose variation has significant influence on the product fit, performance, service life, or producibility. A process key characteristic is the manufacturing process whose variation is essential to manage variation resulting part or feature. So I won't get into that. I think we're having a webinar on key characteristics and how they're identified and how they're defined. So I won't get into those here. That's a whole nother subject, but this is where you list them. Okay, now that you have I'm going to say the body of the PFMEA done, everything to the right of the recommended actions, you put your ranking down and you identify which lines you're going to work. So you put down the recommended actions, you kind of put your action plan down here. The actions may be designed or process changes to lower the severity of occurrence. They may be additional controls, improved detection, which will bring that number down. Also note who is responsible. We want to list what, who, when, and then you'll list any actions taken to date as you progress in this action plan. So this is your living part of the PFMEA. This is your action plan, and this is where your corrective actions come in. Again, only design changes impact severity. Okay, and typically, regardless of RPN, if you have a severity of 9 or 10, that should be given a special attention with designed action. So even if you have a lower RPN, if you have a 9 or a 10, in most cases on severity, you're going to be looking at the design to say, how do I remove that issue from occurring, and how do I make sure it doesn't happen and prevent it from happening? If I can't change the design, I really want to prevent it from ever happening. So I want to do preventive controls on that. And again, as actions are completed, you'll rank the new severity occurrence detection scores based upon actual data that you get. You may want to estimate it first to say, is it significant? Are my actions significant enough to bring it down below my threshold? And if they're not, I have to have more robust actions. If they are, if my estimate is below that, I want to validate that estimate when my action is completed by taking data from ongoing production after the corrections are placed on the line. Okay, next slide. So this is kind of an eye chart, but this is how PFMEA for the fuel control module would look. This is actually the example out of 13,004. So the file's a little different, the header's a little different, but the body is really pretty much the same. So again, as time moves on, the forms are being tweaked to make them easier to use, but basically the message is the same. What is my failure mode? How often does it occur? What's the impact to the customer? How good is my detection system for finding that failure before it reaches the next step, the next operation? I'm going to turn it over to Steve here to show you how it all fits together.
Good morning, everybody. My name's Steve Webster. I'm a quality fellow at Collins Aerospace for product development and process control. So I work around a lot of these tools. So what I'm going to do, I'm going to highlight how everything kind of plays as far as all the different forms. And if you want to go to the next slide, we can start with a graphic that kind of throws everything together. What this graphic does is it highlights on the top the product design process as it applies to APQP, and on the back down, I just lost the slide. And on the bottom, we talk about the process development. So you have product development on the top and process development on the bottom. And what this graphic does, we want to step back from the process flow and the PFMEA stuff that was just brought up. The DFMEA and with the product design really feeds into the design verification test report, and then that feeds into a good design, ultimately resulting in a satisfied customer. But these tools also communicate with the DFMEA directly, communicates the KCs and critical items to the process flow diagram, which then pushes the scope of the process flow, feeds into the PFMEA, and ultimately the PFMEA feeds into the control plan, which defines all the controls, and we're going to be having a webinar on that. And ultimately, a good process would be driving work instructions and process controls ultimately into, and the whole process would result in a satisfied customer if all these tools were, linked together the way they are. You've got the DFMEA providing information on testing and then feedback back to the DFMEA. So all these tools that we're talking about here all interact in order for the APQP process to fully realize the benefit of all the tools. They have to be used together and harmoniously. If you want to go to the next slide, we can, I have another graphic that shows kind of how all the linkages fit together from the DFMEA through the process flow PFMEA down to the control plan and ultimately to the work instructions. As you see, we have arrows connecting the different boxes on the different forms. I should note that the classification box could be, the characteristics box on the PF process flow diagram actually came from one of our forms at Collins, and ideally you could have classification. If you look at AS 13004, classification and characteristics are interchangeable. We just had a different nomenclature on our form. But as you can see, classification goes from the DFMEA classification, which really, that column is where all the critical items and the key characteristics reside. They flow into the the process flow diagram, and then ultimately from the process flow diagram directly into the PFMEA. And as you can see, there are also other linkages that happen. Like if you can go back to the previous slide, and I'll show you on the bottom, we could navigate back just once, whoever's managing the slides. Looking at the bottom, you can see that I have an arrow going across with the process steps, which from the process flow diagram, what you do is you define all the process steps, which ideally define the scope of the PFMEA, and all those steps get transferred across, and then you actually work the PFMEA based on the different processes, and then ultimately those process steps also get pushed over into the control plan, and then you focus on all the different control strategies and methodologies that you would use to make sure that all of the risk are accounted for and controls are in place to ensure that you have a good process with solid work instructions. You can go to the other slide again. And so with regard to all these different columns in the forms, they all kind of have a relationship between each other. Like, for instance, potential failure modes of the DFMEA could impact the potential effects of failure on a PFMEA and vice versa. So there's a cause and effect relationship between the different tools and how they play. And the idea here is to make sure that we understand that as, for example, I mean, I could have a design failure that it impacts a process step on a process that you actually are using to realize the product. And you can, but conversely, you could have a process step that has an issue that impacts a product effect or affects a product. So there's a lot of interaction between these forms. And I should note that from the product design risk, which really is the DFMEA, the severity is really something that you need to pull from the DFMEA and make sure that when you're talking about severity, that you look at the product severity and pull that into operations where those products, the product features are realized in the PFMEA, and make sure that you account for them. And I should also note that severity could also, another component of severity would be impact of severity on the actual, maybe the operator or whoever working in the process to make sure that they are safe. So high ranking severity for that also should be included into the PFMEA. And if you look, you can see that incoming sources of variation that was brought up earlier would actually result in causes of failure in the PFMEA coming from the process flow diagram. And all of the information that is in the PFMEA would then be fed into the control plan, and all the key characteristics, classification stuff, as well as the process controls for both prevention and detection should also be driven into the control plan, as well as the effects, the impact of the effects of different failures and things like that. So in this graphic, I just kind of highlighted the control plan as just a repository where all that information goes. We will be doing a webinar and talking in detail about what a control plan is and how it's going to be completed. And ultimately, all this stuff should be done ahead of doing the work instructions and all the information. The control plan should actually be kind of a summary of all the things that are important from both the process design and the product design that would be driven into the work instructions for the operators at the workstation, so they have all this information right in front of them. And that pretty much is the summary of how everything plays. And these forms and all this stuff really is there for the product life cycle. So we're not just talking about creating a DFMEA, a process flow, and a PFMEA just because somebody asked us to and checking that box per se. These forms are in it for the long haul, for the product life, which means that they're going to be evolving over time, and there's going to be a continuous knowledge management type effort that's going to be around these forms, and ultimately that will actually help us to ensure that we have a good design and good processes for the long haul and a satisfied customer as a result of that. And with that said, I'm going to go to the next slide, and we'll talk a little bit about, we brought up earlier, there are a bunch of different places that you can go to get more information. Right on this page, there's a list of different, like we mentioned the S13004 earlier, and SAEJ 1739. I would strongly suggest that you take a look at this page, and if you want further information, I would, we put this here so you can actually pursue gathering more information to help you with working with these tools. And if you want to go to the next slide, this is there's some upcoming webinars. As we can see, we are completing this process flow, process failure mode, effects analysis webinar, and the next one in the queue is the control plan scheduled for November 12th, and followed by measurement system analysis, process capability and control, and PPAP. So hopefully you guys can attend these future webinars. And with that said, I'm going to ask if there are any questions with regard to the content that we delivered today at this webinar. And then I'm going to push it over to Sue.
Yes. I just want to ask the panelists, can you hear me?
Yeah, Sue, we got you.
Oh, that's great.
Yeah, I can hear you.
So I'm going to change the presentation now just so that we can go through some of the questions. We do have quite a few questions, and I just want to set that up for you. So the first question, well, actually, let me introduce myself real quick. My name is Susan Parsons, and I work for the IAQG. I support the product and supply chain strategy stream, which is the PSCI. And then, of course, our main product is the SCMH. So on the screen real quick, I'm just showing you the SCMH, how to get to it, iaqg.org/SCMH. A lot of people have asked questions about the presentations and where they can get a copy. So thank you, panelists, because you've done a great job enticing some interest.
So I can't see your screen. I'm not sure I'm the only one.
Can't see my screen. Oh, thank you for that. I forgot to share. We'll do that now.
Coming in.
There you go.
That's it. Thank you.
Darryl. I appreciate that very much. So this is to respond to all those that have asked for where we're going to find the presentations, and two places actually. You'll find the material in the webinar section, circled there to the right. There will be the webinar itself, which is the presentation. So I will put up a hard copy since so many people have asked for that. Then we will have a recording once we get a time to review it, make sure it sounds good, and then we'll post that. And if necessary, if we can't get through all the questions that are coming in, which I see quite a few, then we'll also post a Q&A document as well, trying to respond to those questions. And if you look at 7, right to the left there, plan and manage, that's where 7.2 will reside. There you click on that, and it will pop open, and you'll be able to get to the actual guidance document in support of APQP. That said, my first question is, what's the detail level request for PFMEA? Every movement of product production?
This is Darryl. I will field that one. It depends. It certainly depends on what you're looking at and how detailed you need to be to get your failure modes and your effects. So I've done them where it should be movement of product. It should be every time the product is changed, at least every time the product is changed. You may not, it has to be deeper, if you will, than just what's my final operation to make the feature. It may be how the product is changed. So you may start with as the product is received and it goes to a process, which is a preliminary process, just to mark it or deburr it or something like that. That is potential failure mode. And I like to also get into what are the outputs of the process from a non-product related thing. What's the document control systems? What's the inventory control systems? How do they work? Because that's a big part of aerospace as well, is having inventory control, having document control. What's the outputs of those and how do those fail? I had a PFMEA where we got down to how how we tighten the bolts on a fixture, because that happened to be the failure mode of a pretty big issue. And we didn't do that across the board, but we had to get to that detail to really find out what was going on with this one failure mode. And it was basically that we didn't lock down the bolts on the fixture, and we ran a production run. Loosened up as we ran it, and we changed the mix of a product. We were pouring two materials together, and the ratio of those two materials got out of whack because the bolt loosened up. So you have to take it to the detail that helps give you the information you're after. And again, let the product speak to you. If you're done a PFMEA and you think you got everything attacked, but you still have returns from the field, you still have rejects in your bucket, you're not deep enough.
Okay. Does there exist some link between safety and PFMEA?
There is 13,004. When we wrote that, we took the safety aspect out of the severity rankings in most cases until we got to failure, which would cause bodily damage. So we didn't really address if an operator gets cut by a burr or maybe the part's too heavy to lift. If you want to get into the safety part of the PFMEA, I think you can do that. You just have to. That's really your slant. 13,004 was more related to what are the product failure modes, not of what are the safety failure modes. So it's not. It's been accomplished. I think 7J standard talks to safety in more detail than 13,004 does.
Okay. Next question. APQP has 2 FMEAs, design and process FMEAs. Any reason why applications/user FMEA is not included in APQP?
I guess this is Steve. The question is that when you're talking about application, are you talking about the failure mode effects and criticality analysis that's a contractual requirement? Whoever asked that question, we might have to get some clarification on that.
Okay, thank you. What is the details expected for a flowchart diagram? For example, if I return my tool during process, I have to add it in my flowchart.
Yes, any movement of material should be included, and our key considerations. Those could be areas that could induce variation. Generally, you could add too much detail or too less of detail, but you need to find that good medium to make sure that you have enough process coverage in order to feed into the PFMEA.
Okay. What is the difference between FMEA, especially effects analysis, and RCCA methodology? My understanding, both methods are prioritizing the solution on the most significant nonconformance issues, nonconformance/issues.
I can. You want to take that one, or you want me to?
Yeah, because this is something I'm very passionate about. On RCCA, root cause corrective action, or AD, is the reaction to a failure after it's occurred, and it's actions that you take as part of that root cause corrective action to eliminate that from occurring again should flow back into your PFMEA as corrective actions into your right side of your PFMEA as well, and become part of the lessons learned in the PFMEA. And in fact, we used our CCA corrective actions and made sure they were validated as part of the PFMEA, as part of our lessons learned, lessons learned activity in fulfillment of 9145 at Honeywell. So an RCCA is after it happens, you're taking corrective action. A PFMEA, potential failure modes effects analysis, is actions you take that you could have before they occur. So this is the planning part of it. So And an RCCA says you had a failure of your system somewhere and you need to react to that failure. Steve, you want to add to that?
I think you highlighted the fact that when we talk potential versus reaction, is the PFMEA is really looking at the potential failures, not ones that have already occurred, but ones that could possibly occur.
Right, right. And if it has occurred, that's a big oops that you, the PFMEA was insufficient in finding that, and you need to go make that to the PFMEA saying, hey, this potential actually did occur, or maybe we didn't have it highlighted. Maybe our detection wasn't as robust as we thought. Maybe the occurrence is higher than we thought. So you need to go back and review the PFMEA.
Okay. Who usually takes the lead creating process flow diagrams? Is it by organization like program, PE, DE, ME, or QE, or by individual?
It would be the process owner.
Yeah, whoever has influence on the process, typically the manufacturing engineer.
All right. This one, I'm going to try this one. It says failure mode equals root cause or outcome? Question.
No, failure mode is not root cause. Failure mode is again, the opposite of the required output. Failure mode is something that I want to be a certain size or a length is not to that size or length. That's the mode. The causes are impacted by my inputs. So it's an input that was not done right, insufficient, or not adequate. So again, that's a big learning point. Is the mode is related to your requirements. Your cause is related to your inputs, off your PFMEA flow diagram. So think about what didn't do that I asked him to do, or what did he need to do that I didn't ask him to do as my failure mode. Say I'm heat treating, and I don't get it hard enough, and my requirement is Rockwell C, 56 Rockwell C, 54 to 56 Rockwell C, and my part comes in at 50 Rockwell C. And I'm not sure if that's too hard or too soft. I'll be honest with you right now. I've been so, but my mode is I'm not to spec. I'm too hard or too soft to my hardness. My cause is that the heat treat oven wasn't set to the right requirements, or the heat treat oven malfunctioned, or something like that. That's my cause. So hopefully I answered that.
That made sense to me. Okay. Are the effects / consequences at the part level or its end use? Question. Or the next step in the flow? Question.
All the above.
Yes.
Okay.
Let me explain that a little bit. We've had a lot of discussion in our team about the effects. In my eyes, the effects are, again, the operator that I use in the part in the system, the organization that's making the part and selling it, and the organization that's using it, and maybe the guy sitting on the airplane. So those are the effects. Now, the detections are related to those effects. So if I'm doing, okay, it's only affecting the operator, which is a severity code that's pretty low, because all I have to do is rework it or scrap it. I can't pass it on if I find it. But my detections are not as robust as if it's at the end of the line and I'm finding at the end of the line and impacts the organization. So my detection could be just a visual inspection by the operator, which typically is a 7 or an 8 in those scales. Now, if I do loss of product at end of line is my effect, that I'm losing it at the shop and I'm impacting schedule, that could be a severity of a higher number than just the operator, but my detection number is going to be higher. I have multiple inspection points and more robust inspection points, so my detection number is going to be lower. So you have to take each line as an individual and look at, okay, who does this impact and how many, what's my detection ability at that impact level?
Okay.
That help? I hope that helps.
The PFMEA can then be read across for the 80% of identical features, and those which are unique will need to be covered by an appendix PFMEA.
That sounds like, I think he's saying that, like, if we had a process baseline FMEA, I'm just reading into this, that you would have, if all the processes were standard across a number of different parts, that you could just have an addendum for the unique activities that, you know, might be based on individual parts. I'm hoping I'm interpreting that correctly.
Well, if not, we'll have a chance to address it during the Q&A.
Yeah.
And it sounds like, you know, it's really about process segment kind of a thing, where you have a baseline PFMEA, and then you have parts that have that are very common, but they have, some parts have unique features that would be captured in an addendum or yeah.
And you can do that various ways. I mean, you can have an addendum, or you can just add separate lines in your PFMEA,
Yeah.
and you can say for part number XYZ, this applies. You can put some notes in there somehow that these lines apply only for part XYZ that we're going to do something special to. And something I didn't address, which this leads me to, you can do product PFMEAs and do it from you know, basically receiving to shipment. Process PFMEAs. You can say, I'm going to do my grinding operation as everything's got to go through the grinding room, and I'm going to do grinding as a PFMEA, and I'm going to connect all my PFMEAs together to have my product PFMEA. So you know, when I was in automotive, I had, you know, we had 1,000 SKUs we sold. So we had a lot of product, but we only had 26 operations that made all those parts. It was painted different, it was marked different, it may have been boxed different, but the process of making that feature or that product, it was a spark plug, was essentially 26 or 27 processes. So I had 27 processes with uniqueness, like you're talking, but I managed 26 PFMEAs. I didn't manage 1,000 PFMEAs then. So you can do that as well. Something I didn't bring up in my part of the speech.
Under which criteria the effects analysis is expected? Under safety, under cost, others, all of them? Is there any standard guidelines supporting this criteria?
Well, anytime you have a defect, it should be on your PFMEA, potential defect. It should be on your PFMEA. So potential defect could be cause a safety issue. A potential defect certainly could cause a cost issue. So those are all things you were trying to make, you know, robust, reduce the cost, improve safety, improve lead time, so you don't have to rework. So those are all benefits of a PFMEA.
Okay. What is the RPN we can use as target?
It's not recommended that you do that. It's recommended that you work on that's a threshold which actually might cause you to game the PFMEA. What you want to do is you want to focus on the top 20 to 30% of the high RPNs, and then also make sure that you capture any high severity failure modes that are like above 8. Include those in that bunch of.
You know, as we said, anything that's got a severity of 9 or 10 should be certainly looked at. And if the severity can't be reduced, you certainly look at prevention as a real opportunity. Now, I will say that when you get to a point of diminishing returns financially, you've got to stop. Also, you've got to know where the pain point is, that you're just going to have your system, but it'll never get beyond your system, or it'll never get out. But the goal is to have 0 defects. The really goal is.
I think there might
you have
be
to look across the whole shop.
Yeah, there might be emphasis on when I talked about how everything fits together. This is Steve. The idea is that, you know, you take the top 20%, but you got to understand that, you know, when you do the APQP process, that it is an evolutionary process that goes for the length of the product life cycle. So you should be continuously revisiting these forms and reevaluating and reprioritizing and constantly, you know, taking actions against areas where you have RPN numbers. As you learn more and more about the process, you should be continually working that. It shouldn't be something that you do once and you're done.
Yeah, the PFMEAs in my old life, the high RPNs became a opportunity to do our annual AOP and corrective actions. They were put into the annual operating plan saying we're going to knock down certain high RPNs in this area this year. We're going to either buy new equipment, buy new test gear, something, but that became a focus of one or two of my continuous improvement opportunities every year was based upon my PFMEAs.
So the theme here is continuous improvement.
Mm-hmm.
You know, to improve your process design and your product design and your process design, you know, across the product life cycle.
Someone has a follow-on question to that, so I just break in. It says, who decides severity number and how is severity decided?
That's decided by your cross-functional team. As a team, you'll get together and establish that ranking criteria. We've provided an example from AS 13004 for that severity ranking criteria. And as a cross-functional team, you want to decide what is your rank. But additionally, you don't want to establish those thresholds. As Steve was mentioning, oftentimes you'll game the system because of that. The key part is to make sure that you continually relook. And as Daryl mentioned, any severity at a rating of 9 or 10 are the key areas to focus on first.
One other comment to add on to that is that the severity comes from the product risk analysis and the DFMEA into the process. That is a team effort on the DFMEA, but you shouldn't overlook pulling product severity numbers into the PFMEA. It's one of the links.
Oh.
Yep.
Next question. 9145 requires traceability of CIs and KCs through the PFD, PFMEA, and control plan. How is that managed within the PFD and the PFMEA?
Can you want me to take that one?
Well, yeah, we can show there's actually columns in each one of those templates that has a classification.
One of the things that I didn't highlight, if you go over to you can use that classification, but you can go to the how it all fits together graphic real quick if you want. That's on slide 30. Ideally, if you look at the arrow going from the DFMEA down to the PFMEA, and it was Daryl brought it up, is the classification column feeds the key characteristic classification column on the process flow diagram where that feature is actually realized. So there's a product feature that has a key characteristic assigned to it by the DFMEA team. The way it works into the PFD is that, or the process flow diagram, is that wherever that feature is realized, where that key characteristic is identified, is where it would reside on the process flow diagram. Then it would be pushed into the PFMEA to understand the different, ways that failure mode can, or that operation can fail, with the KCs coming along for the ride to make sure that controls are pulled through. So I hope that helps.
And then your control plan has the same column on it.
Yep.
And it shows how you control that KC in your control plan, either by statistical process control or some other, 100% inspection or whatever. But it's also, every one of those forms has a classification column that
Right.
exactly starts with the DFMEA going through the PFMEA or PFD to the PFMEA.
Yep.
New question. What is the threshold for risk mitigation RPN when using scale of 1 to 10 for SOD?
Again, we said, you know, you got to be working the problems, and if you have a brand new process, you're going to have a lot of high RPNs. Where if you're really working a more mature product, you have less and less opportunities, and it's by your organization where the pain point is in your organization where you're going to be working those numbers, or by your customer. Your customer may have a driven number. In most cases, they don't. They just want to see that you're working, continually improving the process. And so there's no hard number out there, but you know, there's a lot of rule of thumbs. You can't just let them go. At the same time, you can't work them until you're basically economically not making money on the product anymore.
For a new project, is what PFMEA is needed for each service, or is it global, created by project leader?
For new product, again, it's you need a product PFMEA from basically when the material receives in the door to when you ship it, as per 9145. You can use similar to PFMEAs to start from. That's really if they're done well and they're solid, that's what you want to do. So you do need a PFMEA for everything. Now, who does it? Again, it's not one person. It's a team function. You need people that are knowledgeable about the processes. You need people that are knowledgeable about PFMEAs. If you don't have that in your organization, if your people aren't trained, you need a facilitator. You'll need somebody that leads the event that says we're going to do these on these scheduled events. We're going to continue to work this. I'm going to call meetings. I'm going to be the barrier buster that says if you're too busy doing something else, I need some of your time to get these done. I'm going to have to go see somebody to get either more resources or more time or something to get them done. But there is no one person that does them, and there's no one organization that does them.
Okay. This person is stating, in our risk management processes, severity never changes, only frequency. Frequency changes based on actions/detections. Question?
Frequency only changes with occurrence. Occurrence is related to your frequency. If you're changing the process, you impact the frequency. If you change the inspection of that process, you impact the detection. If you change design, you change the severity of the failure mode.
Good answer. Last three SEB, OCC, and DET columns seem unconnected with the analysis info that generated the first three scores. There's a suggestion. Maybe a review would be better than using the same chart, mixing old info and new scores.
I think that goes back to you're really looking at your preventive and detective control columns when you're doing those scores, right? You want to make sure that you have an improvement in your ability to detect and primarily, hopefully, to prevent. So what that's saying is if you have a high RPN, it's saying that your preventive and detective controls need to be improved. So I don't know if that answers the question. And the idea of recalculating those scores, like I think Daryl, you brought it up, is that it's not, you don't just put those scores and you actually have to execute the actions and have them be tested before you can add those scores. Make sure that the actions are effective.
Final mention of designed experiments or regression analysis to identify significant factors for new products and processes.
Those are certainly tools you can use to look at how your process change may occur, may make a output more capable or product process more capable. So we don't talk to those, but so those design of experiments, regression analysis, NOVAs are all opportunities to say, did my change that I'm making do what I want, as we just talked about, and what's the impact? Is my capability now, instead of a 3 CPK, is it a 5 CPK? And am I centered? So you certainly can use those tools, and design of experiments or can tell you what are the big knobs you want to control more. It'll maybe tell you where you want to put better detection systems, saying, if I have a process, what are the knobs that are insignificant if I turn them? And I have one knob that's really important, and okay, so I want to put more fidelity or more control on that part of the process. So we don't address them, but they're certainly useful tools. I mean, there's a lot of tools out there, fishbone analysis, and we didn't address. We're not saying how to get there. We're just saying how to establish the opportunity. I guess show you the opportunity where to use those tools.
Okay. And we've got many, many more questions. And I think at this time, I'm just going to do one or two more. But it looks like that I'll be passing. If you were sent in a question and you didn't get a response during this recorded webinar, we will try to do our best to put something together for a Q&A and also post it along with the webinar itself, the recording, and a Q&A. And we're also, as a reminder, people are asking again, the section 7.2 will contain all of the APQP guidance. The webinars, specifically this one, will have the presentation. We are looking into taking some of the information from these webinars and doing further improvements with the material in the Supply Chain Management Handbook. So there's a button over there to your left where it says what's new. When we publish something new, you'll see it there. You'll also have in the appendix section, the farthest to the right, there is an alphabetical list. I'm not sure if everybody's aware of that, but in that alphabetical list is every single topic that the SCMH touches on. Because this is not built all-encompassing. This is built on a pull, prioritizing what people want to see in the SCMH. So you'll see the list. If you type in a topic, you'll find out where it is. You also have the search function to the left there, SCMH search. If you type in control plan, it will pop up the different guidance topics and include a discussion on that. So with that, rather than go to another question, because it would be taken out of order, does any of the panelists have any last minute things they would like to add or conclude with?
Well, I can't emphasize.
Go ahead, Steve. No.
I can't emphasize enough how, in order for this whole thing to work, that you have to treat it as a living, breathing thing, and how all the forms and everything that we're talking about here are related and need to be continuously updated from the beginning through the product life cycle.
Yes, these are indeed not artifacts. They are living documents, and each organization should make sure that they fit your system and that ensures coverage on your entire product life cycle.
Agreed. I think this was very informative. I would say let the process talk to you. I mean, the process map is, in my eyes, is the start of it all. The better you know your process, the better you know your failure modes, the better you know your inputs. And I walk the process, and every time I see the operator pick something up, I'm saying, okay, that's an input. How does that input affect my FMEA?
The other thing that might be a key thing here is looking at AS 9145 is making sure you have the timing right for, introducing all these things in accordance with the phases in the APQP process.
Right.
You don't want to do all this stuff at the last minute.
No, you don't You don't want to write the book at the end.
No.
If you look on these documents, there's always three
Yeah.
blocks. There's prototype, pre-production, and production. So, you know, prototype is early on. Pre-production is, you know, I'm just getting ready to make my, if you will, my fair run. And then production says, now I've used my information from my fair run and I've used other information and I'm ready to document this. This is what I'm going to live with as a document. So there is certainly a maturity path there.
Yep.
Okay. Well, I thank you as panelists for making this such a successful webinar. I also want to thank everybody, all the attendees, for showing up today and taking the time out of your busy schedules to listen in. We look forward to sharing more with you at upcoming webinars, all of which you'll find announced on the announcements page of the SCMH. And if you register on the SCMH, you'll also get an invitation to the upcoming webinars. And of course, all of the APQP guidance is found in section 7.2. Thank you, everyone. Have a great day.